an associate professor and heading the Vellore. Having close to 15 years of experience in teaching, research, and industry, in addition, he was the former head of the Department of Design and Automation, School of Mechanical Engineering, VIT Vellore. He is a life member of ISAMPE. He received the BE degree in Mechanical Engineering from the Bharatiyar University, Coimbatore, ME degree in Computer-Aided Design from the Anna University, Chennai, and the PhD degree in Mechanical Engineering from NIT Warangal. He published several book chapters and research articles in Scopus Essay Journal. He has filed close to 10 patents, which include 1 international patent. His research area includes product lifecycle management, collaborative engineering, product process knowledge-based engineering for higher productive design and innovation, design for additive manufacturing, 3D and 4D printing. Without much introduction, we extend warm welcome in the name of this assembly and the prestigious institution, Jyoti Engineering College, Thrissur. The success of this program is the enthusiasm of the active participation of the delegates. We extend a warm welcome to all the delegates assembled here. Welcome all. I hand over the session to Dr. Arun sir. Hello. Hello.
Yes. Can I start?
Yes, sir.
Okay. I hope you can see my screen. Okay. Good morning, everybody. Congratulations to the organizers of Jyoti Engineering College for making this faculty development program possible. And I'm happy to see that more than 100 plus participants have been joining to understand the latest what is happening in the field of product design, especially when we have the new technologies coming into picture, especially the 3D printing, 4D printing, and now we have been listening about even 5D printing. And the whole thing is changing because products are no more virtual. People want to see the products in their hands so that you can touch, feel, and get an experience of how the product is all about. So with that, we will just get into the the agenda, what we want to see today over the next 1.5 hours or so. We will just see the what is additive manufacturing, what is 3D printing, just an introduction about all that. We will just get into 3D printing, what are the latest technologies and what are the trends or the changes that are happening across the world in the area of 3D printing, and we will see some of the applications also. I will spend some time in talking about 3D bioprinting, which is creating waves in the medical field and the industry. And then slowly we will get on to understand what is 4D printing and what are the kind of advancements that are there and we will look at what the future holds for us as faculty and engineers who are in this particular field. So I'm sure you are aware of this particular definition. The term called as additive manufacturing, which is referring to as a process by which you have digital 3D data, and you are using this data to deposit material in a layer by layer form, and thus making the complete product. So this is a definition by the ASTM, International Committee F42, and this plays a very significant role because till then we only knew the subtractive technology where we kept on removing material, and especially when in metals, so much of material is getting wasted that we never know how much of loss is accounted to that. But came in additive manufacturing, where without in fact losing any material, or literally very little material we are going to lose, but we ended up making products faster and with a better finish. So that brought in a very big change in the kind of technology product designers and people who are into new products are developing. So first we need to understand what is basically a 3D printer. I'm sure all of you are aware of the normal printer, the 2D printer, where we used to print black and white A4 sheets and A3 sheets, both color and black and white. But then nowadays we have the so-called 3D printers, which added the Z dimension to it. So we don't have to print anymore in 2D. We can actually get a actually almost to scale 3D printed objects where you can actually feel the products in your hand. So little getting into more specifics is basically it's helping designers and more specifically prototype engineers to understand their design in a better way rather than just looking at a 2D picture. So this has changed everything, because when you say 3D printing, it is just an offshoot of something called rapid manufacturing or rapid prototyping. And when you say rapid, it's basically fast. Yeah, I'm sure all of you are aware of this particular thing, that nowadays you are able to print a product within an hour's time. And even the cost of printing has come down so much that you are actually able to buy a 3D printer almost equivalent to a cost of a normal 2D printer. In fact, some of my students here have actually bought a printer and kept it in the rooms because they don't want to depend on the printer that is available in the lab because it has become so cheap. 4 or 5 students are able to pool some money and they're able to buy a printer on their own. And all it requires is a software. You just have to, and a CAD software. You just have to plug and play, and then you are able to print at a very fast pace. So this has changed a lot of things over the years, and there's a lot of advancement over it. Because the moment you have a 3D model, it becomes very good in actually communicating your ideas. Okay, it becomes an excellent visual aid. At the same time, it also can be used for testing. You don't actually require the metal prototypes anymore. You can use this 3D printed prototypes to test and then to study your product in a better manner. And it also helps you to create tooling in a faster manner, and you don't have to spend a lot of time depending on a third party to make your tools. And with the advancement of this technology, you're actually able to make production grade quality material, and which has been accepted by the industry. And that's the reason why there's a lot of focus in this particular area. So just a quick recap of what 3D printing technique is all about. I'm sure most of you are aware, but just to get a feel of the whole concept, we'll just run through this particular thing. is first and foremost, you require a CAD model. And from the CAD model, we will develop something called as the STL format, which is basically the input for the 3D printer. And in the software itself, the STL format is basically nothing but, the whole product or the model is sliced into a number of layers depending on the accuracy you want. And then the whole thing is sent to the 3D printer. And then the 3D printer understands the stereolithographic format, and then based on the lowest slide layer, it starts printing one layer over the other, and then finally, over a period of time, finishes the complete product. And then all you have to do is take it up, clean it up, and then start using right away. So that's what happens nowadays with a lot of advancement. You can have n number of softwares which are compatible to 3D printing. All you require is it has to be a decent 3D model software, CAD model software, which can give you a solid model, and this can give you better finish. Once you are able to do it, you can directly get into a 3D printer. And also, I'm sure you're aware that with the development that is taking place, we also don't have to create a solid model. We can actually get a model from the third-party scanner, which we are now called as 3D scanner, which also has become very cheap, that you can use a 3D scanner and simply scan the product of your liking, and you can get all this scanned data and then directly take it into your 3D printer. It becomes much more easier. So even a person who doesn't know CAD is not worried now, because the system takes care of converting a physical model into a CAD model based on your 3D scanner. And you can directly import this scanned model into the 3D printer, and then you can directly print. So this helps us, helps not only engineers but also non-technical people to use this technology to make value out of this particular technology. By if you look at even jewelry people who are having nowadays are having 3D printers in their smartphones, wherein they are able to print complex geometries and then do a gold plate or a silver plating or even platinum plating, and they are able to sell. In fact, we even came across a few companies in Bombay where they are actually making crores of revenue literally every month just on 3D printing, and then coating with jewelry grade materials. So this has been a hit. So you don't have to be technically strong to understand 3D printing. Once you know you have the requisite software and the hardware, you can simply go ahead and start printing. So likewise, it all depends. Once you understand the nitty-gritties of the technology, you will understand that given the complexity, you have to do some pre-processing to understand how good should be your layer thickness, so that you get a better finish compared to the standard, by default thicknesses adapted by some of the softwares. So once you understand the nitty-gritties of the model that you want to print, whether it is having some internal cavities or is it having some thin wall sections, depending on the complexity of your component, you can start using the right parameters, and you will get better finish product at the end of the day using the 3D printing machine, right? So with this, we will, depending on what product it is, doesn't matter how complex or what kind of material you want to use, you are able to print, which wasn't practically possible even before this technology came into existence. So I'm sure all of you would have seen a 3D printer will look something like this, where you have a printer, a nozzle, which can move in the XY direction, and some of the printers can even move in the Z direction. And you have a platform which will toggle in the direction of the printer, so that you are able to move the base either in the upward direction or the lower downward direction, depending on the setting of your printer, and then you are able to finish your printing process. So you need to understand the kind of material that has been used. Earlier, there's initial materials such as nylon and PLA and all these things. But nowadays we have a lot of what do you call advancement, that people even started printing metal using 3D printers. Of course, this is a little bit expensive, but over a period of time, I'm sure the cost of metal 3D printing will come down, and this will become commercialized. Of course, I'm sure you're aware that Wipro and IIC Bangalore just last year had commercialized one metal 3D printer in their campus, where industry are also collaborating, so that you are able to make production grade products directly printed out of a 3D printer. So no more, you don't have to depend on the conventional style of machining or material removal. Irrespective of the complex models you have, like a turbine blade, you can directly print using a metal 3D printer, and you're able to achieve in no matter of time. The beauty over here is you can actually commercialize. I mean, you can actually whatever may be the complexity, you can custom print the product you want. There's no need for you to, I only if you order 10,000 samples or 1,000 samples, I'll make the product. Okay, because I need to invest on the tooling. In this case, I don't require anything. Whatever may be the customization, I just have to, I just require a 3D model, and then I will go ahead and print the model and get it to you. Depending on the complexity, the time required will vary. So the whole thing started off when the process of stereolithography was patented in 1986. Mind you, I would like to emphasize on the term called patented. Only when you patent or publish such kind of work will the general public understand there's some work happening over here, and people will start appreciating what has been happening. So what happened over here was, some material was given, and you are able to print like what you are able to see over on your screen, and people were awe with it, that how come we are able to create such complex shapes in less amount of time. So where did it all come from? It's not something very new. This was the what do you call, the thing was there almost in 1800s. If you look at if you look at the Greeks, that was there. They used something like this to build monuments, okay, which are still existing in the world. And they actually did this by actually building blocks over each other. So the same concept actually was used. What we see now in the present 3D printer is we are actually doing it layer by layer. Just that the thickness of the layer is different. So the hero of this whole story is, the credit goes to Charles Hull of 3D Systems, who first developed the 3D printer in 1984. And he was the one who coined it, the whole technology called as stereolithography. And the word is so famous that the STL format is, in other words, called as the stereolithographic format. But I'm sure you're aware that STL stands for Standard Tessellation Language. Yeah, but you see the like what we call as a photocopier has Xerox. I'm going to take a Xerox, but in actual, you end up you are actually doing a photocopy. But the machine, the product from Xerox company made it so famous that we started using in our day-to-day life, and that's what happened over here. Very similar, it's a revolution over here, that the term, the file, which was supposed to be called as Standard Tessellation Language File, STL, invariably ended up being called as a stereolithographic file. Yeah, so that's the credit that goes to this particular person, and he was the first person to develop this particular technology, and it's been patented, and also a lot of papers have come over this. And he did this in Japan, and this is where the first 3D printer was there. And if you look at the applications, you have n number of applications. You just name the area of use, and you'll find 3D printers there. In fact, 3D printers have found their application in gaming. Nowadays, even food is getting printed using 3D printers. I'm sure you'll be surprised at this. A lot of medical devices have been printed because it's all custom depending on the patient, especially the area of prosthetics, where you have to build custom fingers and custom hands, especially when there's a fracture or there's an amputation. Okay, you have to have custom built things. So this is where 3D printing has been applied extensively. And then it has also been extensively used in fashion and retail industry. Nowadays, even clothing is getting printed using this particular technology. And definitely jewelry. Jewelry is the one of the first outputs of applications of fashion, where you'll have a lot of custom-made 3D printed jewelry available in the market. Likewise, this technology is also found a lot of applications in the defense sector and even space, where nowadays the existing generation aircrafts, where you no more have spare parts, and if you want to have to replace a spare part which is no more available, you can actually use this particular technology to print that custom made product part and then fix it back into your aircraft. And even nowadays, people are talking about 3D printing directly in space. And in fact, even they are looking at projects where can you print directly 3D print material in Mars. With the latest travel to Mars planet, people are trying to see whether can you actually print directly on Mars and make houses there, because it is definitely extremely difficult. You have to, if you want to make a sort of a house there for the scientists to stay, it is practically impossible for you to build a complete house from on Earth, then transport that to Mars and assemble it there. Rather, it would have been it will be more cheaper and economical if you can actually directly print on the planet Mars. So we never know the future how it's going to turn, but it will be very interesting to see how this technology is going to aid. Likewise, you look at more applications. This is definitely used by a lot of industrial designers, where industrial designers are known to make excellent and beautiful products, and to understand the products better, they will like to have a physical model, and instead of doing a clay model or a thermocol model or a model which with some sort of POP material, they can actually directly 3D print the model. Of course, it can be slightly expensive in the initial stages, but you will get actual feel. In fact, you will actually start printing colorful models with the different kind of materials you are able to get in the market. Likewise, even in automotive nowadays, even very recently, we had a lot of interaction with a lot of automotive companies in Chennai who keep coming to our campus, and they keep telling that they've been deploying large-scale 3D printing, because nowadays, where some parts of your car dashboard is actually 3D printed, you never know, because they don't tell you the process behind it. So you can see one of the cars over here, which is totally 3D printed. The outer shell is totally 3D printed, and you are able to actually commercialize this particular product, which is 3D printed. In fact, this application is also there in architecture. Even civil people use this extensively. Nowadays, I'm sure you have heard of houses getting 3D printed using concrete as the raw material, and they're able to build a full-fledged house by simply printing concrete layer by layer, which forms the wall of the house. And so this has also been used in the architecture, and they also are able to get, because of the complexities, especially in a lot of monuments that has been coming up in different places. How complex it is, it doesn't matter. You are able to print this particular their models. And I'm sure you would have seen the kind of the different kind of chocolates that are available in the market.
Excuse me, sir. This is not audible.
Hello. There is no audible.
Yeah.
Yes, sir. Now audible.
Okay. Where is the slide, sir? Hello. Slides are not seen. Hello. Hello.
So slide not visible.
Hello.
Sir, it has shown actually he has left the meeting.
Okay.
Okay, I'm sorry, I didn't know that I left the meeting because once you put a full screen over here, I can only look at a plain screen. Praveen, can you hear me?
Yes, sir.
Okay, thank you. Okay, I don't know how much I've missed. Yeah, okay, so I'll just continue with this that, sorry, yeah. So they made up this particular plate, which is custom built for this particular patient. And then they did a small surgery and they inserted this particular plate onto the skull and then grafted back the skin. And over a period of time, it looked normal. And a third person who's looking at this lady will never know that there's a metal which is made up of titanium, printed in titanium, is actually fixed onto her head. And a person who is looking the first time at her will never know that she had an accident. So that is the kind of advancement 3D printing has. You are able to print using a material called as titanium itself, and this is possible when you get when you play around with the CT scan data from the MRI machine, and then using the CT scan data, you are able to make a CAD model of the requisite portion. and then you can custom print this to fit to your skull. So this is definitely a very good application, where of course it is definitely expensive because you're using titanium and all that. But over a period of time, I'm sure the cost of it will decrease. And not only that, I'm sure it will help a lot of people who had such kind of accidents so that they can get back to their normal life. And likewise, even this particular area with dentistry, where you need to replace the complete jaw, and this technology can be used extensively, and it helps people go back to their routine life without any stigma. Right, and like I just said earlier, this is another patient, just again, this is a real-time case study.
Hello, sir. The audience not available.
Yeah, I think I'm back. I'm sorry, I think there are some connection issues. Yeah, am I better? Can you hear me?
Yes, sir.
Yeah, so I just, can you see my screen?
Yes, it is audible.
Thank
You
you.
can continue.
Thank you. So what is happening over here is now we have seen this application, and there's a lot of toys are getting printed now, and it's definitely helpful for kids who can have custom toys. And another area where this is getting extensively used is the replacement, especially when a lot of products are going offline, off shelf. You don't have a replacement. You can actually do a custom build replacement for your kind of products. Likewise, given whatever may be the shape of the product, you are able to print whatever may be the complexity of the product, whatever color you want to give, as long as you're able to get the material and the color of the color grade you want, you are able to print the particular product. Yeah, so you'll also be surprised to know that the Airbus 350, which is again a lot of advancement has happened, that they've been using a lot of composite materials, and even these composite materials have been 3D printed. And in fact, the latest version of Airbus also, in fact, even Boeing has a lot of 3D printed products in their aircraft. Next time when you fly, you please try to look out whether you can identify a 3D printed product in your cabin, because it will be very, very difficult for you to distinguish the two different structures. Yeah, so let's go ahead. We have some animated characters also which can be 3D printed. Yes, and we have another important application where we have prosthetics, where people are able to replace amputated hands and legs with this particular technology. I just want to play a small video. I hope it will be beneficial. So what you can see over here is the 3D printed prosthetic limb, which can help a lot of patients do a lot of activities. And this is definitely a boon to a lot of people who are less privileged because of some accidents or something. In fact, even naturally, if they are slightly disadvantaged, this can help them overcome that kind of burden. Yeah, and nowadays even the operating systems, some like Windows and all, are directly giving you free plugins for you to set up a printer at home. So you don't have to depend on anybody.
बोलिए सर, आपका इडली पूरा बंद होके पानी हो गया है। आपका इडली ठंडा हो गया।
Okay, so I think each time you'll have to bother me. I joined. Okay, fine. So I'm sorry about it. I'm sorry again. I think I've lost connection. I'm sure all of you are facing this issue when you take online classes to your students. But this is my first time I'm using Google Meet. But anyways, doesn't matter. Just let me know whenever I get kicked out of the meeting because of the network issue. Happy to join back. So let's continue. So yeah, so like I said,
Hello. 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 Audio problem.
Left the meeting again.
There's a lot of connection issues today. So can you hear me, Praveen?
Yes, sir. Now it's okay.
Thank you. Okay, so I hope you can see me, all of you. Yeah, so that's what we have seen. And then what happens over here is we have an algorithm where definitely we require the CT or the MRI images, and we do a 2D, 3D segmentation, and then generate point cloud data out of it. And using all these softwares, we have to do some kind of biomodeling where it requires a lot of accuracy. And definitely there is more complexity over here because I told you, since it's a human body, you have to be very, very careful as to how it's going to be extremely more complex, and you require high level of accuracy to achieve something like this. So you can see over here also, there are experiments that have been done where you are able to actually print a total tissue. In fact, a liver or a heart is again getting printed over here. But of course, this is all very, very in the nascent stages. It will take a lot of time for it to get commercialized into the market. But the interesting part over here, if you look at, is this industry is growing multifold. And if you look at, in fact, in 2019 itself, it was $1 billion industry, and it's expected to go at a CAGR of 17.4% in this particular duration. And that means you will see more of such kind of implants happening on a regular basis, because the more validation happens, you are able to bring down the cost of this kind of printing, and more people can get benefited. Another statistics over here, if you can look at, you see, if you look at the US market, because a lot of things happen over there from a developed country, you can see that, the kind of, you look at the market size that has been booming over the years, and look at the forecast that, literally in the next 5-10 years, you'll find a lot of things happening, in a lot of improvements and a lot of changes happening in this particular area of 3D bioprinting. And especially at this current pandemic situation, COVID-19, there is definitely more demand over here, because you find issues where the lungs are getting damaged, and definitely people are looking at an exponential growth in this particular area. I'm sure by this time you're aware that a lot of people in different education institutions and industries were actually overnight printing, mask and giving to distributing to different police personnel and medical people, so that you are able to have a shield in front of your face, which is actually 3D printed. And they could do this at a very fast pace because of the technology that is available, and because the printer is actually very cheap. So you can also see that, if you look at the applications over here, a lot of applications in terms of medical, dental, people are also able to develop some kind of biosensors using this particular technology. People are developing something called as bioinks, which I will come to that shortly. And also people are exploring whether we can print food, and in fact even meat, using this particular technology. So if you look at the value, market value, it's a huge number. Even people can't imagine how come this technology is going to generate this kind of revenue over a period of years. Yes, so even in academia, a lot of companies are actually, a lot of universities are trying to do a lot of niche research, and they're actually incubating in their own universities. And I can give you some examples where, some companies are able to start commercializing their own research, and they're able to make a lot of products from their research. If you look at the commercial market itself, a lot of work has been going into developing bio ink and bio paper, because definitely these are the prime materials for you to print. Without the materials, you cannot definitely not print. So you have a lot of scope in making biocompatible materials themselves. And definitely, to deal with such kind of materials, you have to have requisite softwares, because all these materials are non-linear, and so you have to do some kind of analysis. In fact, even do some kind of design to understand how they will react in real time. And definitely, you have to have the requisite hardware. And I'm sure a lot of industries are doing a lot of work in this to able to commercialize each of these particular sectors. And this also has created a revolution in the pharma industry. Of late, I have read that nowadays you can actually 3D print your own medicine, depending on the kind of industry 4.0 revolution, where everything has been monitored. You can actually monitor a patient, and let's say, just for layman discussion, let's say you're going to have you have fever, and you need to consume a 650 mg paracetamol. And they give, if you go to the doctor, he will say, okay, please have 650 mg paracetamol for the next 5 days. But over a period of time, I'm sure you will know, but within 3 days, your temperature is actually going to dip. So why do you actually have to consume 650 mg paracetamol? Instead of which, if you have a sensor embedded, and this can monitor your level of infection in your body, and instead of again having a 650 mg paracetamol, if you can 3D print the paracetamol so that you just have to consume the required level of paracetamol, how great it will be. So, of course, it's a very simple example where I'm sure nobody will want to 3D print a paracetamol, because it's you get it at very cheap. But if you look at some kind of drugs which are very, very expensive, and you cannot afford it, especially where life-saving drugs are there, if you can 3D print these drugs, so that you can bring the cost down, depending on the kind of the customization you have for your particular customer, or patient, you can actually do this. And this is also creating a lot of waves in the industry. And you'll hear a lot of advancements where top companies such as L'Oreal are actually doing 3D bioprinting of even doing cosmetics as well as testing on skin care products. So there's a lot of revenue that is getting generated over here, and but you have, when there's so much of interest over here, definitely there's you should have to look at the flip side. There's a lot of challenges over here, because when you say challenge, the first challenge is basically when you have insert a foreign body into a biological structure, it will definitely tend to react. So you have to be very, very careful what kind of transformation, transplant you're going to do, because this is something which every doctor, every patient will experience. because the moment you have third party goes into your human body, your body will definitely react. So, and then how do we, you need to visualize this even before inserting that into your body. And you need to understand the physical, the chemical and the biological impact where this products can have on your human body. Likewise, it calls for fabricating this complex tissues, and so that it can emulate what is there in your human body. Yeah, so that are the challenges, and this have been widely used in the industry, like what you can see on your screen. A lot of advancement have been making. I'm quoting a paper in way back in 2014, where you can see that they are trying to 3D print tissues using biological material. Yeah, and also this paper dated back 2014. They are able to print, your trachea, which is basically hollow, and they also have, succeeded in printing livers and tongue. But of course, I will not say it is directly available now, commercialized, but a lot of work do happen over here. So what you basically require over here, I'm trying to skip some portions because I think it's a lot of in there. Yeah, what is required over here is you need to understand the printing process, because you have to have some kind of material called as bio ink. Okay, and what does this bio ink consist of? It's basically your cells. Yeah, and this cell you have to mix with something called as hydrogel, and this you have to form like a this slide will talk better. That I'm sure you will hear of stem cells, and these stem cells have to get cultured so that they grow in a laboratory environment. And once they are cultured, they have to you have to collate them with a hydrogel, and this will form something called as bio ink. And this is what you tend to use again to print your print your tissues in a controlled environment. So this becomes even more complex, and this is what has been used for the bioprinting. Right. So when having known this, we also have to be aware that we don't. When you say printing, it's not restricted to one kind of material. Yeah, when especially when you have composites around, we have to definitely have to look at customizing prototypes with mixing different kind of materials, mixing materials with different kind of ratios. In fact, mixing different grades of materials, and that's where we have the beauty of 3D printing advancing with the use of something called as smart materials. And basically, with the advancement over here, we are able to print materials which are smart enough, and that's where we have something called as the 4D printing. And this is a beautiful technology that is evolving. A lot of work has been happening in this area, and interestingly, 4D printing, the term itself was coined by an MIT professor, Skylar Tibbets, and where he defined, I quote, the use of 3D printer in the creation of objects which change or alter the shape when they are removed from a 3D printer. The objective is that objects made self-assemble when being exposed to air, heat, or water. This is caused by a chemical reaction due to the materials utilized in the manufacturing process. So this is what he has defined as a 3D printing process. And basically what has happened over here is, instead of using your typical nylon or PLA or plastic, what has happened is we tend to use material which can transform, and something which can be pre-programmed to react to a particular stimuli. And what happens here in a 3D printer is basically you have the material over here, and you simply insert into your 3D printer, and it gives you a static structure. Whereas in 4D printing, you use something called as a smart material. It can be in form of a resin or even like this, and you have to print this material, which can behave differently when you are having a stimulus attached to this particular thing. So what happens over here, I will try to show you a video so that it helps you understand better. I'll just play this. I hope it will be you can see over here, once that printed object is put into water, how it starts behaving, like a flower. So that is the kind of advancement that has happened. That is what is that makes it more interesting, because the whole thing gets activated the moment you are putting this into a different medium. And when you say medium, it basically you're looking at a stimulus. Either it can be physical or in chemical shape. Either you put in hot water, or you change the composition of air, or you apply some kind of humidity, you change the pH value, or the light intensity, or the temperature. Either of it, you'll find the shape getting changed, and it can give a lot of applications because of this particular thing. And interestingly, if you look at the prediction over here, you see the kind of revenue that this market is poised to. Literally, it's again going to $500 million by 2025. There's a lot of work that is happening over here, and there's a lot of demand of 4D printing technology and the materials, specifically in military, defense, aerospace, and even healthcare industries. So if you look at the interesting part over here is the kind of applications that is coming out. We India are far behind. Okay, only now very few people have started working in this particular area. But if you look at the states, they've done a lot of work. And if you see over a period of years, the number of publications have been drastically increasing. So you can find a lot of researchers have understood the potential in this particular field. And then a lot of papers have been coming out over a period of time. And in 2019 itself, 107 papers have been published. And even if you look at the citation over a period of time, it has been increasing. So definitely this encourages also, this should encourage people to start researching in this particular field, and help us do a lot of contribute towards the society at large. So just to get into the fundamentals, is the building blocks of 4D printing are you definitely require a 3D printing facility, and what is this kind of stimulus you want to use for this particular process to stimulate your 3D printed component. And then the material you're going to use, which I already mentioned, it has to be a smart material, and you need to understand what is the interaction that happens over here. And you also have to do the look at the mathematical modeling, because you need to understand the physics of how these shapes are happening. So if you look at the software itself, the 4D printing software, you will see that this lot of work has to happen in understanding the modeling. We also have to look at the simulation aspect of it. We need to also there's a lot of work happening in the printing management, because you need to print accurately. At the same time, you also have to have an idea about what is the hardware and the software you're going to use, what is the slicing mechanism you're going to use, and you have to also look at the feedback mechanism to monitor your whole technology. So when you come to that, you also should have an idea what are the different kind of materials that have been used over here, especially in 4D printing. Primarily, we have something called as shape memory alloys and shape memory polymers. we also have hydrogels, which has, you've seen, it has been used in bio 3D printing. And then we also have a lot of composite materials which have been used in this kind of field. So when you say alloy, a shape memory alloy, basically it tends to change its shape when exposed to temperature or some kind of load. And these alloys are basically, exhibit something called a superelastic behavior because they undergo a phase change transformation when exposed to a stimuli. So I'm not getting into a lot of details here, but we just look at one application over here, where this particular alloy is used to, which is getting actuated by magnetic fields, and it is used as an actuator. I will again play a video over here. You can see this particular shape memory alloy, which has been used as an actuator.
Sir, it's not audible.
It's not audible, huh? Oh, 1 minute. Oh, what's happening? It's fine. Yeah. Is it audible now?
Yes, sir. But just you are showing the video, or you are explaining that along with the videos?
No, I'm not explaining. It's actually the audio, the video itself is having an audio. So I'm not sure whether you're able to hear that.
Then it's okay, sir. Okay, sir. So we thought we thought we are not audible. That's why. Okay, okay. Carry on, sir. Carry on, sir.
Yeah, fine. Thank you. So you can see that this is the linear actuator, which is using the industry grade memory alloy, shape memory alloy for actuation. And this is again having a lot of applications in the industry, specifically the actuation part of it. Likewise, we also I don't know whether you heard of this particular alloy, nitinol, which has become a major player in the biomedical field. And you can see the application of the polymer over here. Again, I would like to play a video so that it's much more easy to understand. You can see how the filament is has changed shape when exposed to hot water, and you see how this can be used. Okay, I think it's not buffering well. One more thing I will show you and go to the next one. Yeah, so what here you can see is basically, you are having a self-folding, something like an origami box or a pyramid or something which you saw on the video, some material like this, which once, you expose it to hot water or, something or a different kind of medium, it will actually fold or unfold. So this can definitely have plenty of applications. So that's what 4D printing is all about. So what happens here, you need to understand, is basically both of them are using shape memory materials. And shape memory polymers are much more lighter. They're found to be more flexible because they're of the polymeric nature. And that's why they also exhibit a higher degree of biocompatibility when compared to smart material alloys. And also, in addition, the recovery rate in SMP is, it consumes less energy while, doing the memory programming. So another example over here I can show you is the acrylate-based SMP, where you can see that, if you look at the wafer exposed to a certain temperature, okay, it changes shape. And then once again, you remove the temperature, within literally 2 minutes, it gets back to its original shape. So you can see over here, the permanent shape and the recovered shape both are almost the same. And because of the phase change, you can see that they are looking very different. So this is the advantage of doing 4D printing. And you can actually modify your existing 3D printer to act like a 4D printer, just by doing having some attachments, like modifying it with an air circulation system to help you cool down the SMP below the glass transition temperature or something like that. Likewise, you also can use inject-based non-contact technique to print these kind of materials, because inject printing encourages higher biocompatible. It's basically a highly biocompatible process, and you can do better things using inject printing or even stereolithography. But stereolithography or inject-based printing is preferred over FDM because of the nature of the material that has been used. Because most of the time we end up using resins, some kind of resins for 4D printing. Yeah, and not only that, FDM cannot produce very smooth or highly finished products when you're using 4D printing. You require more of such kind of products which you can see on your screen, because you need more flexibility when it comes to 4D printing. Likewise, you can see one more also having applications in soft robotics, where you can see over here a gripper. When it comes in contact with this particular screw on your screen, starts gripping the object on its own because of the change of shape. And this also used smart memory polymers over here. Yeah, and maybe I can show you another few more examples over here, where you can see a deformed shape of the Tower of Paris, it regains its original shape when exposed to a medium. Likewise, you can see different examples. Again, I think I will play a video over here. I hope it buffers correctly so that you get a feel of the process. So you can see a miniature model of the Eiffel Tower, which is deformed. But once inserted in this particular medium, you see how it recovers the shape. It's buffering, yeah. I don't know why the video is not buffering properly, I think. Let's play it once again over here. Yeah, yeah. Okay, now I think it's better visible. You can see that, how it is changing shape. Yeah. Yeah. You can see how it is regaining its original shape from a deformed shape. So you see how it has actually regained its original shape, and that's the very good application of the smart polymer, which you just saw in this particular video. I had actually another example in this. Yeah, this is the one. I hope it plays correctly. Yeah. Showing clipping. Yeah, okay. There's some issue with buffering. I don't know why, because of the connection issue, I think. It will actually, you can see it actually grips the screw. I'm sorry, it's not buffering properly. You can actually see it, bend. Let's try once more. I'm sorry, I don't know whether it's actually visible, that you can actually see it grip the screw and take it and taken up. So that is another application. You can see that, where, we can actually print foldable material, and then they can behave in a manner you want it to behave. That's the way you have to program the whole thing. So there's another example over here is a prosthetic finger, basically a direct application of soft robotics, where you can see over here you have the nodes, and depending on the kind of the way you have programmed it, you can actually you can see the this is basically a thermoplastic elastomer, and you see how they're flexible enough to create a new shape altogether. So you had a finger which was basically straight up, but you can see how they're bending because of the shape memory effect. Likewise, we also have a stent, which you can see over here, which is again 4D printed, okay, which is basically personalized to the particular patient. So there's a lot of advancement in 4D printing. I don't know whether I'm running short of time, but you can see that basically there's a lot of advancements that will take place in basically the software itself. And we also need to have more understanding of the multifunctional smart materials, because as of now, these materials are slightly more expensive. But if we can procure them, we can actually build print 4D printing, print products of our choice. And then we also have to require high resolution printers for this. But I think nowadays we are able to afford such kind of printers in the market. So there's a lot of applications in 4D printing. Okay, maybe actually you can see applications in clothing. You can see applications in food, in health. It also, they're trying to. I've been even reading about transport, where you have potholes which can heal on its own. A lot of things advancements are happening, and I'm happy to share this paper with you, where we as a team have worked on this along with our partner in Crankfield, UK, where we have collated all this information, the fundamentals of 4D printing, the opportunities and the challenges which are there. And most of the slides which you have seen have been taken from this particular paper. I would recommend you can actually download the paper and get more insight into what has been talked or the future of 4D printing and the materials that have been used in this particular field. Yeah, so that's it from my side. I would like to thank you for this opportunity. I'm sure the audience had an insight to what is 3D printing, the advancements, and a slight exposure to what is 4D printing. And we at VAT are also doing some kind of little bit work in 4D printing. We also have been trying to move ahead in this particular technology. Let's see in future, hope we can contribute in a better way. So you're free to contact me, maybe me or any of our team members. You're free to contact, and maybe we can even share more. Thank you. So if you have any questions, you're free to ask.
Hello, sir.
Yes.
It was a wonderful session. Sir, I had a doubt that in a self-folding box and triangular figure you showed, in
Yes.
that we can see that there is a black material and there is a white material. So is it two different materials or?
Yeah, it's two different materials. So that's what one is what actuates the whole thing. So you can actually custom make this. Maybe it can be a single material at the same time, or you can have a mix of two materials. One will actuate, do the actuation. The other one will do the folding for you. So it depends on how you want to customize your thing. You have to create your material combination like that.
Okay, so in that case, I think the black piece will be the smart material, and the other one will be a common 3D material.
Yes. In that example, yes.
Okay. Okay, so can we make the entire structure with the same smart material, and can we incorporate that shape changing phenomenon to some portions alone? Is it possible? Like that?
It is possible. Yes, it is possible.
Okay,
We have tried it in our lab also. It actually unfolds, but the whole thing was made of one material. But this we are trying to use different material and try to have a mixture of basically a composite, and then try to see whether how it's going to actuate.
Okay. Thank you, sir.
Thank you.
Sir?
Yes.
Yeah. What's the difference between 3D and the 4D, sir? It may be only for the material or any smart material?
No, basically 4D, when you say, it's with the factor of time. So here the time plays an important factor. And the kind of actuation, the medium you're trying to use. So over a period of time, you can see that your 3D printed material is going to act differently. So in this case, let's say you take a smart material, basically a box which is totally folded, and the moment you put it in the hot water, it actually expands, opens up.
Okay, sir.
Yeah.
Thank you.
Thank you.
Sir, I have a doubt.
Yes.
Yeah. Regarding the 3D printing and 4D printing machine, are there like any big significant difference, or is it more of the material that plays a role in the 4D printing? Like you mentioned, SMA, nitinol.
Yes.
And nitinol is,
definitely material will definitely have a major role, because a nylon which you want to print is not a smart material. It's not going to actuate. It cannot change its shape. Okay. Likewise, if you take metal also, it's not going to change its shape. So a smart polymer is definitely required over here, has material. So material plays an important role. That's what we say. Either it has to be a hydrogel, or it has to be a smart material alloy or a polymer.
Yeah, but regarding the temperature, because we melt the feed rod in 3D printing and then we print it.
Yes.
And when we use it in 4D printing, again the melting occurs.
Yes.
Right?
Yes.
So how does the behavior can be controlled?
Yeah, in this we have to actually regulate the melting over here, because once it forms, we can actually use an attachment over here, maybe to faster cool, so that it doesn't go back to its original shape, but we can control its shape because of the additional cooling that has been put over here. Like I said, we can constrain this even below its glass transition temperature. So we can use an attachment to force feed the air or some kind of gas to control the melting.
Okay, thank you, sir.
Yeah.
Any other questions?
Sir, can you suggest me any simulation software for the additive manufacturing, sir? Best one.
Software as such, basically in our lab, we are actually trying to simulate what we are trying to do is we are doing an abacus, because it's a non-linear material. We are using a 4D printer as such to directly, we are actually buying the resin and trying to mix it with the combination what we require. then try to feed into the 4D printer and trying to print it. And then we are actually doing experimental work as of now. But the analysis part of it, we are doing in Abacus.
Okay, sir. Thank you, sir.
Hello. Hello.
Yes.
Hello, sir. I have one doubt, sir. Hello.
Yes, please. I can hear you.
Sir, like a 3D printing machine, is it any available for creating 4D objects using 4D printing machine?
No, see, when you say 4D, because you are looking at the material itself, which is different. It is not same as the 3D printing materials. Definitely, it calls for a change of machine. So, because you have to ensure the environment is taken care of. So, ideally, you will end up buying a 4D printer because of the kind of material you're using and the kind of atmosphere you require for this printing the product.
Sir, this kind of machine is available in market, sir?
Yeah, it is available. Yes.
Good. Thank you, sir.
Thank you.
So can you please describe me what is the difference between, or why we mention like additive manufacturing in a different name, and say we have a different name like 3D printing and 4D printing, or does it comes under additive manufacturing, or what is the difference?
See, additive manufacturing is basically the whole umbrella party, I will say, because the moment we stopped subtracting material and started adding material, that whole technology, and end of the day, we manufacture products. So that's the reason subtractive manufacturing became additive manufacturing. Okay, earlier we used to call it machining. Nobody used the term called subtractive manufacturing because it was taken for granted that you actually remove material. But the moment the technology came in where we started adding material and going to create the product, then came the significance of something called a subtractive manufacturing, where earlier it was called machining, where we used to remove material. Whereas in this case, we are adding material. And the machine which we started using was called as a 3D printer, because whatever you want to print, we are used to the term called printer. And since we are doing a 3D printing, we ended up calling it as a 3D printer. So, and now we are, since we are using a different kind of material, which needs to be, which are using a fourth medium, which is time, you ended up calling as a 4D printer. That's all.
Thank you, sir. So it means that 3D printing or 4D printing technologies are one of the
offshoots of additive manufacturing. Yes.
Yeah. Okay.
Yes.
And what are the what we say difficulties on adapting these 3D printing and 4D printing into the market nowadays?
It's basically, we have applications are there, but again, it's the cost. You have to have the shape memory polymers available to you. So sometimes it calls to import some kind of these polymers, which are sometimes not available locally. So we have some challenges like that. Plus, the whole study of it requires a lot of dedicated effort. And we also should require a lot of funding to do some kind of activity like this. So, like I said, it is still in the nascent stage. Definitely, we people can do some more work over here and contribute over here.
Okay, thank you, sir.
Yeah.
Any other questions? Respected Dr. Arun sir and friends, the session delivered by Dr. Arun sir was exploring to the details of new trends in industry, and it was really enriching. The concept of course inspired us. I take this opportunity to express our gratitude to the resource person. As a token of love and gratitude, I request this eminent personality to accept our sincere words of thank you. Thank you, dear sir.
Thank you. Thank you so much. I hope it was enriching to you.
Yes.
Something new. Thank you so much.
Okay, thank you. Also, we express a word of thank you to all the delegates of this session. Thank you very much. Tomorrow's session will be handled by Dr. Sivaraman, Director, Industry Institute Relation, EGS Pillai Engineering College, Nagapattinam. Thank you all.